Okay, so here we are. I can solve a logarithmic equation, 5.5 notes, okay? So I'm going to call on some people to do this. Let's see. Give me the answers. So switching it from log format. So the first four are switching from log format to exponent format, okay? Sydney, can you switch out number 1 for me? Okay. Number 2, Lucas, can you do number 2 for me? Okay, we'll do it now. What's your base? So what's your exponent? Okay, you got to switch it out. So your input, it needs to switch input and output. 1/16 is already the input. Do you see it? So 1/16 is already inside, so it cannot be the exponent. So what's your actual exponent? Okay. Equals 1/16. Okay. As a comment, if you did 2 to the 1/16, that's actually equivalent to the 16th root of 2, and you'd be saying that was -4. So if you kind of look at what it actually is, you should be able to tell that maybe you didn't do it right. One of your key things on this is what needs to happen. The base is the base, okay? 2 is the base here, 2 is still the base. So log base or exponent base, still the same base, because they are the inverse, that is the inverse operation you're doing. So cube versus cube root, 4th power versus 4th root, it's still a 4th index set, okay? Then what happens is you need to remember that these need to switch. So that needs to come from the in to the out. It needs to be the answer as the input. And then your answer needs to go in as your input, okay? So it looks a little weird because we're moving up on the math scale, and the further we go up on math, the weirder our syntax gets. But essentially, you want to just remember base remains base, and then you need to switch the input and the output, okay? Vincent, how about number 3? Okay, how about number 4? Deacon, how about you?
I'm not sure. I was going to do that.
Okay, so what is your question?
I don't know how to count it.
Okay, do you know what your base is?
Is it 10? Or I'm not sure.
Okay, so we're a little confused. Okay, on 3, how did we know the base was 10? Because there wasn't one. So this is what we just did in the notes. So essentially, if I see log and whatever, okay, that is log base 10. That's the common log, okay? That's how we knew that 3 was base 10, because we don't see a base. So when I don't see a base, it's the common set. Okay, on 4, what I'm actually seeing is ln, right? So ln, if I write it as a log, ln is base what? So that's what I'm really doing, okay? So Deacon, what is my base now? What's the letter I put in there?
Oh, E?
E, my base is E. Remember, it's that weirdo number, okay? So referring to it as E, because we don't want to have to write 2.71828 ... Okay? We don't want to have to write out 10 decimal places. So we're being lazy and saying, you know, I'm just going to name it E so I don't have to do that. Because for accuracy, if I wanted accurate answers, I would need to probably write it out every single time to at least 10 decimal places, and I don't want to. So E is my base. Then you have 2 choices. You have X and you have 5. Which one will become the exponent? Carson, what do you think?
5.
Okay, 5 is the exponent, and then what's my answer?
X.
Deacon, is this making sense? So the base remains the base. Then you take your input, output, and you switch them. So input on the logarithm, exponent on the exponential, okay? All right, so that's changing from log form to exponent form. We also would like to be able to go backwards, changing from exponent form back to log form. So first things first, we identify the base. The base is 4. Stitcher, can you tell me the log form for number 1? What's my base? Okay, what's my input? What's my answer? Okay, there you go. Ta-da. Okay, Mary, how about number 2?
Log base 3 inputting 181, and the output is, or the answer is
Okay, and I just use parentheses because I like my parentheses, so I just added them in there randomly. Okay, number 3, Kennedy, how about you? Log, agree or disagree? Some of us are agreeing, some of us are thumbs up, some of us are thumbs down, okay? I agree with the X. Okay, let's look at this again. In the original problem, what number is the base? So if this is the base number, does that make sense that 9 is the base? Then it needs to match your log base. The bases don't change because your operation is basically inverse. So if it's a square root, it's a square. If it's a cube root, it's a cube. If it's log base e, it's e to the x, okay? So bases remain the same. So if you identify your base first, it makes it a little easier because what's my real base? 9. Okay, I will make a comment to you guys that that right there is a final numeric answer. By solving, that would be an answer because it's essentially x equals log base 9 of 3.2, which is a number. There's no variables in there. Log is an operation. Log is do something. You're doing something on a number to another number, so that is numeric. If I wanted the decimal equivalent value to this, what would I need to do? What's the very last thing we did on the note card, guys? We changed our base. Okay, so if I want a decimal equivalent, that's my numeric answer. That is as far as I can go without a calculator. Actually, you can do other things, but it's pain because you have to guess and check like for 5 decimal places. So I'm going to change this to ln. ln divided by ln, okay? So I need to change it into 2 log base e problems. What number goes on the top? ln of what number? What number's on the top, guys? 9 or 3.2? What number is on the bottom? Oh, not 3.9. That was bad. Bad typo. 3.2 and 9 on the bottom. Okay. So one of the things we're remembering, that one goes up and that one goes down, right? So if I evaluate that using my handy dandy awesome calculator tool, what do I get? 3.2, 9, oops. Oh no. Okay, maybe I use my handy dandy calculator too. Perhaps if I can actually type in my problem correctly, that might be a challenge for me today, whatever. Okay, I get 0.529. So that is my, if I ask for a decimal answer, that's your decimal answer. Okay, this would be what I expect to see. This is what justifies your answer, okay? You need to have this on your paper before I just get a number on there. All right. Are we good with number 3? Is anyone having questions about what I did at the end? Okay, I'm doing that because I don't have log base 9 on here, so I have to do a little tricky maneuver. Okay, it's like I can't get to the answer because there's a giant roadblock, but I can go around the edges and get to my house. Okay, so that's essentially what I'm doing. Okay, so laws of exponents. Trying to solve these using laws of exponents. This is cast your mind back into the dim and distant past before we went online, okay? What do you have to do if you can, okay? I want to do what with the 16 and the 64? I want to make them the same base. So 16 and 64, what would be a number I could use as my base value? Okay, I'm seeing some fingers held up. I can use 4, or I could use 2 would also work, okay? I could use 4 or I could use 2. Should work either way, okay? So 16 is 2 to the power of 4. And 64, what is 64? 2 to the power of what? 2 to the power of 6, I think. Or 4 to the power of 2 equals 4 to the power of 3. Because 64 is one of those weird numbers that you have multiple options. Choose one. It's an or statement, not do both, okay? So when you choose one of those, and when you solve it, and when you get an answer. Is anyone stuck on the next step? Okay, looking at C. Here's what I know. ln is log base E. Okay? If you have a log base E and exponential base E, what do you know about those? They cancel each other out because they are inverses. So you get 2x equals 6 and x equals what? 3. Okay, on D. Okay, I saw a couple people do this. Do not multiply 3 into the 10. You cannot do that because there is an exponent on there. So multiplication, guys, is lower level than exponents. Exponent is higher and more powerful, and so you can't do a regular math operation multiplication into something with an exponent. So it's 3 times that value with an exponent. What I need to do is get rid of the 3. If I can't multiply it, what do I have to do instead? I can't really multiply the 3, so how do I get rid of it? Divide it. Opposite. Okay, seriously, guys, if your mouse are not staying on, we will be sending out emails, okay? Seriously. I'm not joking. So 10 to the 3 minus x equals 7 over 3. Now I'm looking at it. What I'm seeing is my exponent. Where's my variable? The variable of x is inside the exponent, okay? So I cannot solve this directly, and also I can't just change 10 and 7/3 to the same base value because they're totally different kind of numbers. So I want to switch it out to a log form. As a logarithm, what is my base? My base is still 10. What's my input? What's my answer? Okay. Now I'm just solving for x. Okay, get x by itself. I'm looking right here. What do I have to do to get x by itself? Should we minus the 3? So what I'm going to get is negative x equals negative 3 plus log base 10. Actually, I'm not even going to write that. Log of 7/3 because I don't need to write it because it's always base 10. And then that negative, I need to switch all my signs, either multiplying or dividing -1. There's my answer. Is that is the numeric answer? Is that all numbers? Over here, is this all numbers?
Yeah.
Okay, that's not my decimal answer, but that is my numeric answer, yeah.
Why did you change the sign?
Because right here I had a -x. So I originally had negative, so I want positive, which changes all the signs. If you basically either multiply by -1 or divide by -1, will change the signs across. So if I have a negative answer, negative variable, then across the other part of the problem, if to make it positive, you just change your signs. That's what multiplying by a negative does, essentially, right? And I want it positive, right? Okay, so now, ta-da, calculator. So your final decimal answer should be x equals 2.632. Okay. Okay, so these are like the main strategies. You switch out the bases, change it from log form to exponent form, solve, use your calculator. If the base is not E or 10, you need to use the change the base formula to figure out your final answer, okay? All right, so I'd like you to keep working on these. Hopefully that made sense for C and D if we were getting a little stuck on those. Okay, so try the next ones. I'll come around and help you. Okay, so for the rest of these, you want to think about switching them out. So it depends on where your variable is. Your variable is inside. You need it not inside the operation. So the operation is logarithm. The base is 3. So what I want to do is change it to a base of 3. So a base of 3, an exponent of 2, because the exponent and the answer switch, 3x minus 1. So that turns into 9 equals 3x minus 1, and then I just solve it. So add 1, 3x equals 10, divide by the 3, x equals 10 thirds. Okay, on the next one, again, here's my base. X is in the exponent, so I need to move it. So how do I move it? Is I change it to a logarithm, base 2. Input is then 1.5. Answer is the exponent negative x. Okay, so I just need that negative not here, so I'm going to multiply by -1 both sides. Yes,
Were there a pair of car keys in here?
you can go look. I didn't really see any. I didn't see any, so I don't think, I think you left, I didn't see any car keys, so I don't think that there was any in here. All right, so continuing, x equals then negative log base 2 of 1.5. So my final answer, I need to change the base. So it's going to turn into negative ln of 1.5 over ln of 2. So switching out my base from log 2 to ln. Also notice I only have one negative. If I put negative top and bottom, essentially that turns it positive. All right. Oh. Okay, so sorry, I had to go get a calculator. So I just do this on my calculator, negative ln 1.5 divided by ln of 2. So x x equals 0. Negative 0.585 rounded to 3 decimal places. Okay. Okay, same idea. Okay, notice on this one, x is already outside. I think 216 is a power 6, so I'm going to just try 6 squared is 36, 6 cubed, 6 to the third. Oh, hey, look, that is 216, check, because that kind of looks good. Otherwise, you can change the base, or do ln of 216 over ln of 6 in the end. So what I get is 3 equals 3x plus 2.
Attention students, this is a reminder that the Sweethearts meeting is in classroom H107. Have a great day.
So subtract the 2 from both sides. 3x equals 1. Divide by the 3, x equals 1/3. All right, next one. So once again, my exponent, my variable is up in the exponent, so I need to switch it out. That's going to be log base e of 9 equals 4x plus 3. Okay, then essentially I just continue on and I just solve that. So subtracting the 3, 4x equals negative 3 plus ln, I'm going to change it to ln instead of log base e, ln of 9, and then divide the whole thing by 4. So be careful on your division because you're dividing the entire set. Dividing everything by 4, okay? So you can, generally what you're going to want to do is write it like that, negative 3 plus ln of 9 all over 4. And then you can just evaluate that on your calculator. So you should get, and you should check that this is what you get. Negative 3 plus ln of 9. You do it in one step, you're going to need to put in parentheses. So basically on your calculator, you're going to want to group that top because otherwise it will not divide through. It will only divide the second part. And my answer is negative 0.201 rounded to 3 decimal places. All right, hopefully that was helpful in helping you understand how to solve logarithm problems. Essentially, it's just switching out the format if you need to. So being able to switch from log format to exponential format and then using your different strategies to solve. Bye-bye.